tell me how JK flip-flop works. Utkarsha, what is difference between JK flip-flop and SR flip-flop? Utkarsha, are you there? मोबाईल एकीकडे आहे आणि त्या एकीकडे दिसतात. ओके, वैष्णवी.
Yes, ma'am.
So what is difference between JK flip-flop and SR flip-flop?
JK flip-flop is faster than SR.
Okay, it is faster. Okay. So is it the only difference between JK flip-flop and SR flip-flop?
Ma'am, the disadvantage of SR flip-flop is overcome in a JK flip-flop.
Hello.
Ma'am, the disadvantage of SR flip-flop is overcome in
JK
a
flip-flop
JK flip-flop.
overcomes disadvantage of SR flip-flop. So in a SR flip-flop, whenever both inputs, that is the J and K, that are high, that time we get forbidden condition. That means that time we get Q and Q bar both high. Okay? So that should be avoided. And so there is an invention for of the JK flip-flop. Now, do you know who has invented JK flip-flop? And why the name of this flip-flop is like a JK flip-flop? So this flip-flop was invented by Jack Kilby, and the name after him to this flip-flop, that is a JK flip-flop. Okay. So here uh, now we are going to discuss about this JK flip-flop. Already you have studied about this flip-flop in digital systems, but still we are going to discuss about this, and then after that we are going to write VHDL code for that. Okay. So JK flip-flop, that is a combination of SR flip-flop and T flip-flop. Okay. So it behaves like a SR flip-flop when J is considering J is equal to S and K is equal to R. Okay. For all the inputs, but except J is equal to K, that is equal to 1. That means when both these inputs are 1, then in that condition it will not behave like a SR flip-flop, but at that condition it behaves like a T flip-flop. Okay, that means it toggles the its state. Okay, so if Q is equal to 1 in that case, then it becomes 0, or if Q is equal to 0, then it becomes 1. Okay, so that means it toggles the state. Okay, so that is the difference between the uh, JK flip-flop and SR flip-flop. Okay, so here whenever both the inputs are 0, that means J and K that are 0 in that condition, output state remains same. Okay, like that of a SR flip-flop. That means it whatever is the earlier state, output remains as that of one. Okay. When J is equal to 0 and K is equal to 1, then it output gets resetted and therefore output becomes 0. That means Q becomes 0 in that case. Okay. Then For j is equal to 1 and k is equal to 0, output becomes 1. Okay, so whatever may be the earlier output, but in that condition output becomes 1. And for both these inputs that are high, in that condition output becomes uh, inverse or complement of the earlier state. Okay, that means if it is a 0, then it becomes 1, or if it is a 1, then it becomes 0. Okay, so it toggles the values. That is the JK flip flop. Now it happens whenever there is a clock event happens. Okay, that means whenever there is a change in the clock, in that case, there is a change in the output. Okay, so we are going to write now VHDL code for this JK flip flop. So I'll share screen with the Xilinx. So now in the same flip-flop project, we are going to have one more flip-flop, and that is a JK flip-flop. So I will go to the implementation. Okay, now as I am going to implement this JK flip-flop, so I will switch my view to implementation and then right click on this project, that is a flip-flop, and then add a new source. Okay. So now as I am going to write a VHDL code, so I will click, so select source, that is a VHDL model, and then give the name to this flip flop, that is a JK flip flop. Okay, so JKFF. Then click on next. Okay, and now I'll give uh, port names. Okay, so port name, that is a J, that is one of the input, then K, that is another input, and clock. So these are the three inputs, and Q and Q bar, these are the two outputs. All are single bit. Okay. And then click on the next. So these pins will get uh, as a ports in a entity. Okay. So click on finish, and here you will find VHDL code for this entity. So here this is the library declaration part, and after that there is an entity declaration. So you can find in an entity there are different there are the ports, input ports as well as output ports that are present. All are of the STD logic. So whenever you are not mentioning the data type, that time it will automatically take it as a STD underscore logic. Okay, and then here it is the architecture of this entity. Okay, so we need to now write code here. So let us begin with this architecture. So now you tell me what will be the code for this flip flop. Okay, you are going to tell me what will be the code, and I'm just going to type it. We have seen SR flip flop code in the morning session, so it will be similar to that, only there will be change when the condition, that is j is equal to k and k equal to j is equal to 1 and k equal to 1 occurs. Okay, that much is the change, otherwise all the code will remain same. Okay, so now you tell me what will be the code. Harshal? morning program? Yes or no?
Yes, ma'am.
Okay, so now tell me. So we want to write a code for JK flip-flop where truth table for JK flip-flop is like when J is equal to 0, K equal to 0, output is equal to Qn. That means the earlier state. Okay. When J is equal to 0, K equal to 1, output will be 0. That means Q is equal to 0. When J equal to 1, K equal to 0, output will be equal to 1. And when J equal to 1, K equal to also 1, then output will be Qn bar, where Qn is nothing but the earlier state, and we are considering output, that means Qn plus 1 state. Okay. So now you tell me what will be output, what will be code here. Nitin,
Where
Rahul, सगळे मोबाईल ठेवून कुठे फिरायला गेले की काय?
if
खिशात
J
घेऊनच
is
चालू आहे
equal to
फक्त.
K,
सुनील,
Hello, madam.
काय असणार आहे कोड?
ma'am, त्याखाली प्रोसेस स्टेटमेंट येईल ना, प्रोसेस ऑफ क्लॉक.
Wait a minute, I have
त्यानंतर
closed this window, so I need to again once open this. I will open project and then flip flop and that take it. Okay. So now here we need to have a process where the sensitivity parameter for this is a clock. Okay. Then we are going to declare one variable, that is a temp, which will be present only for this particular process.
std logic type.
Then begin. Okay. After that,
If clock is equal to 1 and clock event
if okay, if in the bracket clock equal to 1,
and clock hash event bracket complete. Then खाली ma'am, if j is equal to 0 and k is equal to 0, then temp is assigned to temp, semicolon. Then temp is assigned to temp. Ma'am, less than and equal to का colon and equal.
Yes, we have defined this as a
Variable
variable, so it will be
colon and equal
colon
to
equal.
temp.
Okay. Then after that, it will be else if,
Else if j is equal to 1 and k is equal to j is equal to 0 and k is equal to 1, then ma'am, j is equal to 0 inverted
yes.
com, com
Okay. I purposely did that mistake. Okay, so you have told. So let it be. Okay, now it should be in a single quote. Also, this should be in a single quote. Okay. Then temp
then
is,
temp is assigned to 0.
then else if,
J is equal to 1 and k is equal to 1. J is equal to 1 and k is equal to 0. Then temp is assigned to 1. Else if j is equal to 1 and k is equal to 1, then temp is assigned to not of temp.
temp is assigned to not of temp. Yes.
Not of temp.
Okay. Then next,
End if and so end of both if
end of, end if. Then after that,
both if uh, end if
once again one end if. Okay. Okay. Then next,
q is assigned to temp and q bar is assigned to not of temp. End process end
okay.
yes
Okay. Okay.
completed.
So Sunil, is this code is correct? Okay, I'll save this. Now tell me what is the error? here syntax error near this line 51. Else if j is equal to 1. Okay. So here there should be space. Okay. Now, okay. So let us go for syntax checking. Okay. Now let us write test bench code for this. We want to associate with this JK flip flop. So click on that, click on next, and then finish. Okay. So what changes we need to do? We need to add stimulus here. So we'll go to this and then J that we are going to assign for the first time as a 0. Okay. That will be assigned to 1. Okay, already J and K that initial value are 0. So I'm not once again going to have that value. So here you can see J is equal to 0 and K is equal to 0. These are the initial values. So let us start with the next values. So I am first of all I'm taking J equal to 1 and K equal to 1. Okay, then
Q is equal to 0.
Q equal to 0. Oh, that is output. So we don't need to mention this. That okay. Whenever we are writing test bench, that time we just need to write what are the inputs. Okay. So automatically it will check for what will be the output. So that means these are the test vectors that we are mentioning. So we just need to give the inputs or state the inputs. So here so there will be 4 combinations for the input. So we have already one combination was there. So we have mentioned here 3 combination. Let us save this. Okay, and let us go for the simulation. And then select a test bench of this JK flip flop from this all these sources that are available. So we have selected this test bench and then check for the syntax. So that is completed successfully. So we will simulate this. So as we have not mentioned what will be the initial state for outputs. So whenever j equal to 0 and k equal to 0, there will be an initialized state for q and q bar because we need to first initialize that, but that we have not initialized. So it will be taking the value that is in loop. Okay. Now, when j is equal to 0 and k equal to 1, so it will be in a reset condition. So output will be 0 and that is a q will be 0 and q bar will be 1. Okay, so you can find here q is equal to 0 and q bar that is equal to 1. Whenever j equal to 1 and k equal to 0, you can see when clock is equal to 1, in that condition q will be equal to 1 and q bar that will be equal to 0. And when both inputs are high, so now in an earlier condition q was 1 and q bar was 0. So here when now j and k both becomes equal that and equal to 1, that time q will become 0 and q bar will become 1. That means it will toggle its value and then it will change. Okay. Now here you can see that after that for each of the clock cycle it will toggle the values. Okay. So here you can see for the next positive cycle here q value is changed to 1 and q bar to 1. Then again after that you can see here q is changed to 0, q bar to 1. So you can see here this. So this action will take place till both these inputs are high. Okay, so for each of the cycle, it will toggle the value. That means here, whenever j and k are equal to 1, that time it will behave like a toggle flip-flop. And when it has the different values, that means when it has the value that is a 0 0 or 1 0 or 0 1, so in that case it will behave like a SR flip-flop. So this is the JK flip-flop. So that is the more advantageous than that of the SR flip-flop, because SR flip-flop in that we avoid the condition where both the inputs are equal to 1. Okay, so that condition we need to avoid. So here that drawback is avoided in this uh, flip-flop. So this is the mostly used flip-flop in the circuitry. Okay. So if anyone has doubt about this, सगळ्यांना लक्षात आलंय आउटपुट कसं चेंज होतं वेवफॉर्म्स बघितल्यानंतर.
Yes, ma'am.
Okay, is there any doubt about this?
No doubt, ma'am.
Okay, so these are the flip-flops. Okay, so these are the different flip-flops that we have seen in this practical. Okay, so here we have simulated SR latch, then we have simulated D flip-flop, T flip-flop, then JK flip-flop and SR flip-flop. Okay, so all these 5 flip-flops that we have simulated here. So if anyone has doubt about any one of these flip-flop, they may ask. Or if you want to see once again all these flip-flops, then we will again open it and just have once again we simulate it. Okay, just कुणाला समजलं नाही असं काही आहे का? So then shall we proceed? Okay, you are not telling anything. समजलं नाही काहीच नाही.
समजलं, ma'am.
बाकीचे okay, that means you are representing all the time, you are representing your class. Is it like that? ओके, ठीक आहे. म्हणजे आता प्राजक्ताने हो म्हटलं की तुम्हाला सगळ्यांना कळालेलं आहे. ठीक आहे. तर आपण मग नेक्स्ट सर्किट बघूयात आपण शिफ्ट रेजिस्टर. ओके, सो वी आर गोइंग टू नाउ simulate shift resistor. So I'll just go to the new project now and then first of all we'll check for the parallel in parallel out shift register. Okay, so 4-bit parallel in, parallel out. So parallel in, parallel out, shift register. Okay, so I'll just have this and okay, PIPO underscore SR. Instead of that, I will just write this as a shift register, and then we will have in this project we will have different sources. So close this simulation window. Okay, click on project name and right click and select source type, that is a VHDL model, and then we are going to write a code for parallel in, parallel out shift register. So give the name to that source. Click on the next. Okay. Now tell me, what are the different ports in parallel in, parallel out shift register? What is mean by shift register first? Tell me.
It is a device which shifts the input to the left side. It is a device which shifts the input.
Okay, it shifts the input, or in another way, it stores the binary data. Okay, so or it can transfer the binary data. That means it shift registers that are used for storing the data, or it can be used for the transferring the data. Okay, so here there are different modes of shift register. One is the parallel in, parallel out, then parallel in, serial out, serial in, parallel out, or serial in, serial out. So these are the different modes of this shift register. So first of all, we are going to see parallel in, parallel out shift register. That means data will be in a parallel mode and it will be out in a parallel mode. Okay. So tell me, what are the different ports in this? Already you have studied about parallel in, parallel out shift register, no?
Yes, ma'am.
Okay. So tell,
Ma'am, D1, D2, D3, and D4, these are the inputs, and
okay.
Q0, Q1, Q2, and Q3 are the outputs, and the clock signal is common to all the flip-flops.
Okay, so I'll first write clock, that is the input. Okay, then instead of writing D0 to D1, D2, D3, I'll just take a bus, that is a vector, and so that is the input. So it is the bus, and it is 4-bit shift register that we are looking for. So we will have the MSB, that is a 3, and LSB 0. Okay, then we have the Q, that is the output. Okay. And that is also we are going to select as a bus. So it will be having in the range of 3 down to 0. That means MSB will be 3 and LSB will be 0. Okay. So why we are doing this? Because we want 4 bits. So here when we are considering bus, so that means there will be in the range of 3 to 0. That means D1, D0, D1, D2, D3. These will be the bits that will be available. Okay. So these are the ports in this source. So click on the next. You will find a summary here, and then after that finish it. Okay, so you will find this library declaration part which will be automatically generated, then entity which will be again automatically generated depending on the pin names that you have given. So here you can see this is the D input, which is a std underscore logic underscore vector type. That means it will be a bus, and the range for this is 3 down to 0. Q is also output port, which is again std underscore logic underscore vector. That means it is again a bus, and it is of 4-bit as the range is 3 down to 0. Okay. Now in architecture, the name given for this architecture, that is a behavioral. We are writing this for this entity, which is a PIPO underscore SR. So now what is the code? So here, as again, whatever are the statements that we are going to have in this architecture, so that we want to be executed as a sequential statement. So we will write a process here. So process and the sensitivity parameter, that is the clock. Then begin of this process. Now what we want actually, whenever there is a clock event, that means whenever there is a rising edge of clock, now in a in parallel out shift register at each of the clock signals. So whatever is the input that is available, that will be available at the output. Okay, so that means for each of the rising edge, जे काही तुमचं इनपुट अवेलेबल असेल इनपुट पिन्सना, ते तुमचं आउटपुटला जाणार आहे. म्हणजेच we need to use a statement that is if clock is equal to 1, and clock event then Q is equal to T. I will just make this as a capital T. It will not make much difference, but still I am writing this as a capital T. Okay, then end of if, then end of process, and end of if. Okay, so this is the just very simple code for this PIPO shift register. ओके, दॅट इज अ पॅरलल इन पॅरलल आउट शिफ्ट रजिस्टर. म्हणजे इथे काय होणार आहे की प्रत्येक क्लॉक सायकलला म्हणजे पॉझिटिव्ह एजला तुमचा Q हा that will be equal to D. Now as we have considered here as a vector, so whatever is the value of D0 that will be assigned to Q0, value of D1 will be assigned to Q1, value of D2 will be assigned to Q2, and value of D3 will be assigned to Q3. Okay, so in that way there will be a assignment of this input to the output that will take place. Okay, now if you have mentioned D0, D1, D2, D3 separately, then you need to write it in that way. That means you need to write in a code that is a Q0 that will be equal to D0, then Q1 that will be equal to Q D1, and in that okay, so in that way you need to write. But here this saves lines in the code, so we have used this vector. Let us save this code, okay, and then check for the syntax. So let us synthesize this, and okay, I have done all the process at a time. So that means it will check the syntax, then it will check for the RTL schematic. So my synthesizing that is completed. So netlist will get generated. So all that things that will done. Okay, so I'll just go for this RTL schematic. So here you can see this. So this is the bus. Okay. Okay, then I choose this, and then now we are going to write a test bench for this code. So this is the test bench code that is generated. So this component that it is declared in this architecture. So you can see here all these ports of this component. Then initially we have assigned value of clock that will be 0 and D, that all the values that we have assigned as a 0. Then clock period that we have as taken as a 10 nanosecond, and then after that we have clock process where we are declaring what will be the on time and off time. Okay. So now here, now we are going to assign input that is a D, that is equal to, now as here now this is a vector, so there should be double quote. Okay. So I'll have this value as a 0 0 0 1, okay, semicolon. I'll minimize the time. I'll make it as a 12 nanosecond. Okay, purposely I'm doing this so you will see the difference. Now again I will take wait for 12 nanosecond, and then I will have the value that is a t is equal to 1010. Okay, so this is the one more input that I am giving. Again I will wait for wait for 15 nanosecond now, and then t that I am going to assign as a 1111. Okay, so these only values that I will take. You can go for the more number of values, but right now I will take just these three. Okay, and then here this is the statements. So I will save this and then go for the simulation. Select the test bench that you have selected, and then inner processes. Expand this iSIM simulator. Check behavioral check syntax. So it has completed successfully. So now we are simulating. So initially at test clock positive edge of the clock, here as the input is 0 0, so output will be also equal to 0 0. Okay. Now after that, here at this positive clock signal, input is 0 0 0 1. So output will be, again you can see it is a 0 0 0 1. Okay. Now this input that remains for the 12 nanosecond. Okay. So whenever here, though the input is changing to the next value, that is a 1010, but when the input clock signal becomes 1, then only there will be changes. Okay. So here the input had changed at this particular time period, but whenever clock signal becomes 1, so then output will change to that value. So now here you can see output is, again it is equal to 1010. Okay, so it will remain till the next value change, and again when there is a rising edge of the clock. Now here you can see input is changing at this particular time. Here actually clock signal is high, but there is no any rising edge of the clock. That means output clock signal is not changing from 0 to 1, and that is why output will not change at this particular position. But here when the clock changes from 0 to 1 and then it becomes 1, output will change, and here then you can see that output that is equal to 1111. Okay. So for the next clock signals you can see as there is no any change, so output will remain as it is. Okay. So this is the parallel in parallel out shift register. Okay, any doubt in this code? This is a very simple code for the parallel in parallel out shift register. कुणाला काही डाऊट आहे?
No, ma'am.
Okay. So this is about the shift register. We are going to see more modes of shift register in the next session. Okay. So for today, we will stop here. If you have no any doubt, otherwise you may ask.